All right, we are solving rational equations today. Go ahead and put your name on here. It is currently second hour when we are recording this. Okay, with rational equations today, we have to solve for two things. The first thing that we're going to solve for is what we are used to solving for, which is our solution. So our solution is what x equals. So we solve for x. Yay. The other thing that we are going to have to solve for today, and the thing that's new about rational equations, is our restrictions. So before I explain to you what our restrictions are and why we have to solve them, I want you guys to go look, where are the x's in these equations? On the bottom. Okay. What is the one number we're not allowed to solve or divide by? 0. So if my x's are in the bottom of my fraction, there is a risk that if certain numbers got plugged in, we would have a 0 in the bottom of our fraction, which we are not allowed to do. So in addition to solving for our solutions today, we are going to solve for our restrictions, which is what x cannot equal. So I'm writing an equal sign with a slash through it. So we solve for what x does equal, and then we also need to solve for what x cannot equal. How we are going to do that is we are going to set the denominator I feel like it's OR. Denominator not equal to 0 and solve. So you're going to set the denominator of your fraction not equal to 0, and then you will solve that. Okay. In Algebra 1 with Mrs. Ho and Coach Zoe in the year 2025 on September 23rd, every time you get a solution and a restriction, they're not going to be the same. Because just in the problems we have today, that doesn't happen. Because right now we have x's in our denominators, but there aren't any x's in our numerator. In future classes, specifically Algebra 2 in 2 years, so you'll take geometry next year and then algebra 2 the year after. So in future classes, once you have x's in your denominator and multiple x's in your denominator plus x's in your numerator, there is a chance that one of your solutions will also be one of your restrictions. So you would solve for your solutions, because you might get more than one solution by then. You would solve for your restrictions, and then at the end you would have to say, but wait, that solution is canceled because it's not allowed to be that. So in Algebra 1, that's not going to happen. But anytime we have an x in the bottom of our fraction, we want to get in the habit of checking for that, because otherwise you're going to get there and you're not going to be in that habit. So if there is an x in the bottom of a fraction in a denominator, we check for a restriction. Any questions right now? Okay, so we're going to go through, we're going to solve, we're going to find our restrictions. If you got questions while we're solving, let us know. Because the x's are in the bottom, the first step of solving these is a little different, and that is we got to get the x's out of the bottom. If something's in the bottom of the fraction, what operation are we doing with it? What operation is it currently, though? Division. So what do we need to do to get it out of the bottom of a fraction? Multiply. So the first thing that we are going to do in all of our problems today is we are going to multiply by the denominator on both sides. So I'm going to take this x plus 5 that's down in the bottom of this fraction. I'm going to multiply by x plus 5 on the left. I'm going to multiply by x plus 5 on the right. And I am going to put it in parentheses because it needs to stay together. So the fraction bar keeps it together, but once I take it out of the bottom, I need to put it in parentheses to keep it together. Okay, so then what we are able to do is this x plus 5 and this x plus 5 would reduce down to 1 and not be there anymore. So that's why we multiply by x plus 5 on both sides. That's why that's our first step. So now we've got 12 equals 4 times the quantity x plus 5. And we are going to solve from here. So this 12 came from here, and then this 4 times x plus 5 came from over here. Okay, any questions right now? Okay, we've got 12 equals. We're going to distribute on the right. 4 times x is 4x. 4 times 5 is 20. Don't write huge because we're going to have something else that we need to do in this box too. I say that hypocritically because I realized I was kind of writing huge. And solve this like a regular equation. We're going to subtract 20 from both sides. Negative 12 minus 20 is negative 8. Equals 4x. And then we divide both sides by 4. We get negative 2 equals x. Okay. On all of our problems today, I put this handy dandy solution box. So when you get your solution, go ahead and flip it around if it's like that. We can put x equals negative 2. If you are a person who wants to solve with x on the left, we could have written this the other way. So we could have done 4 times x plus 5 equals 12, and that would have been completely fine too. Okay. Any questions for solving for my solution? Okay, it's a new first step, but once you get that first step done, it is 1.4 after that. The new part of today, other than that first step, is our restrictions. So now we need to solve for our restrictions. So I am going to cordon off a little bit of space here. So find some space that you can write. And we are going to take just the bottom of the fraction. So just the x plus 5. You are going to have to remember that you take just the bottom of the fraction. It's not set up for you. You have to set this up. You are going to set it not equal to 0. Because the bottom of my fraction isn't allowed to be 0, because what am I not allowed to divide by? 0. Okay, so then I solve this like a regular equation. I'm going to subtract 5 from both sides. I'm going to say x cannot equal negative 5. Because 0 minus 5 is negative 5. And so that will be my restriction. X cannot equal negative 5. Hey, any questions right now? Hey, so in Algebra 2, when you are solving rational equations that are not just first degree, you would get like a whole list of solutions and then maybe a couple restrictions. And so if you had 4 solutions and 2 restrictions, and then you would have to say, okay, well, if one of my solutions is one of my restrictions, I have to cross it off. But we will not have to do that. We're just practicing for in the future if we were to have to do that. All right, next one we've got negative 45 all over 2x minus 3 equals 5. So the first thing that we want to do is get rid of what we're dividing by. So we're going to multiply by it. So we're going to multiply both sides by 2x minus 3 and 2x minus 3. That 2x minus 3 on the left completely cancels out. So, goodbye. And then on this one, I'm going to solve it the other way so you guys can see that we can do this. We can take the 5 times 2x minus 3. I'm going to put that first. Equals. And then I'm going to put the negative 45 on the other side. If you did it the other way, just keep going. You should get the same thing as us. I know some of us prefer to have our x is on the left. So now we'll solve. So distribute. 5 times 2 is 10x. 5 times negative 3 is negative 15 equals negative 45. Okay, I'm going to add 15 to both sides. 10x equals negative 45 plus 15 is negative 30. And I divide both sides by 10. I get x equals negative 3. So that is my solution. Okay. Any questions about solving for the solution? Okay, the other thing that we need to do then is we need to solve for our restriction. So in this one, the bottom of the fraction is 2x minus 3. So we need to take all of that, 2x minus 3. And what is that not allowed to equal? 0. So it's not allowed to equal 0. God knows what's going on. Okay, any questions about setting that up? Okay. We are going to solve that. It is a two-step equation. We're going to add 3 to both sides. We got 2x equals, or sorry, does not equal, 0 plus 3, which is 3. And then we are going to divide both sides by 2. These cancel. And we are going to keep our answer as x cannot equal 3 halves. We are going to leave our answer as an improper fraction. X cannot equal 3 halves. So you will leave your answer as an improper fraction. Do not change it to a decimal, because in this case, we could do an exact decimal. 1.5 is exactly 3 halves. But if it's like 1/3, it's 0.333 continuous, you can't do an exact decimal. So there's no reason in life to round unless you are asked to. And so since we can't always round, we're never going to round. We're always going to leave it as a fraction. And then we are also going to leave things as improper fractions, where even if there's a bigger number on top, we leave it like that. Do not change this to 1.5. I'm not allowed to say I'm going to throw my shoe at you if you change it to 1.5, but I want to say I'm going to throw my shoe at you. Your math career from here for the rest of your life, there is... Coach Zoe, can you think of any, other than word problems, I don't think there's any reason that you should change a fraction to either a mixed number or a decimal. We're going to want things as improper fractions. Because, yes. So once you get to Algebra 2, we're doing a lot of preparing for Algebra 2 today with this lesson. Once you get to Algebra 2, there's a chance you would be asked to plug this back in. So plugging things in as a mixed number is 1,000 times easier. So, or not as a mixed number. I hate mixed numbers. As a improper fraction. Okay? So leave things as an improper fraction. I feel like in elementary school, they like drilled into us to change things to a mixed number. Don't do that. We're done with that. Okay. Any questions about either of these examples? Okay. Do you guys feel like you would be able to solve these on your own yet? Okay. Yeah, I know we have one more. We're going to talk about the one more. Okay. So we've got one more. I just want to see if you have any questions. What is different about this one? Yeah. What's on the bottom? Just an X. Okay. So it looks more complicated. It actually ends up being less complicated. We need to get that X out of the denominator. So just like we did on the other ones, we're going to start by multiplying by it. So multiply by X on both sides. I don't need to put it in parentheses because it has no one to hang out in its parentheses with it. So don't make it feel bad that it's lonely. Just leave it by itself. So those X's cancel. I've got 6 equals negative 3x. And then it actually ends up being less work. It looks more complicated, but it's actually less complicated. Because now all we have to do is divide by negative 3. 6 divided by negative 3 is negative 2 equals x. X equals negative 2. Your answers on these will not always be negative. That is a complete coincidence. And a coincidence that we should probably fix for next year. Alright. Any questions about solving for x? Okay, the restriction on this one is so complicated it's easy. So easy it's complicated. I don't know. What's on the bottom of my fraction? What can the bottom of my fraction not equal? 0. What do I need to do to get that by itself? Nothing. So if it's just x on the bottom, that just means x cannot equal 0. So if it's just an x, that just means x cannot equal 0. Okay, so we saved that one for the end because it's actually simpler, and we didn't want you to think it was so simple the entire time. These notes do not have a back, so you guys can go ahead and glue them in. Stop this video.